Hello everyone. Today I want to start with uniform circular motion. Oh, it is of class XI. So uniform circular motion. Alright. So now you'll be seeing what is uniform circular motion. That means that a ball is traveling along. Wait, I can draw a perfect circle. Alright, a ball is moving along this circle. Alright, and its speed is not changing. Alright, delta speed, there is no delta speed. Alright, but since its velocity keeps changing, alright, since its velocity keeps changing at every single point, it is known as uniformly accelerated motion. Alright, now let's just dive in to the angular world and let's talk about the different terms. Alright, so in the angular world, we don't say how much distance you covered. Alright, in the linear world and the angular world. Alright, in the angular world, you say how much theta you covered. Alright, how big of an angle did you cover? Alright, so this is the angle theta, right? So if it makes one revolution, one entire rotation, it is known as 2 pi radians, right? And now velocity is known as omega. Alright, angular velocity. Alright, and acceleration in the angular world is known as alpha. Alright, which is equal to delta omega upon delta t. Alright, so this is known as angular acceleration. Now we have our basic formulas. S is equal to r theta, alright, where r is the radius. This right here is the radius, alright, and v is equal to r omega and a is equal to r alpha. Alright, these three are very important, and we have v is equal to d upon t, right? Speed is equal to the distance upon a certain time. So just like that, omega, the angular velocity, is how much theta can you cover in a certain amount of time. Alright, so this is one formula, and alpha is equal to w final minus w initial, or omega, upon time. Alright, so now we have the kinematical formulas. Alright, so for these we have v is equal to u plus at, s is equal to ut plus half at square, v square is equal to u square plus 2as, and s is equal to v plus u upon 2 times t, and we just convert all of them into angular notations. Alright, so that means w final is equal to w initial plus alpha t. Alright, theta is equal to w initial t plus half alpha t square. Alright, and w final square, w final square is equal to w initial square plus 2 alpha times theta. Alright, and theta is equal to w final plus w initial upon 2 times time. Alright, now we have an interesting case. Alright, if we have a circle, the time it takes to make a complete rotation around the circle, alright, is known as capital T, which is the time period. Alright, so in order to travel 2 pi radians, how long does it take? And now there is frequency, this is n, which is frequency. Alright, so in 1 seconds, alright, in 1 seconds, how many rotations can you cover? Alright, so in 1 second, how many rotations can you cover? That's just equal to 1 upon time period, right? Are you understanding? The frequency is equal to n is equal to 1 by t. Alright, and now we know that omega is equal to theta by t. Alright, so if we want to calculate the omega of an entire rotation, it will be 2 pi, right, upon the time period t. Alright, so for example, the time period is 0.5 seconds, so the object is rotating really fast. Alright, and we want to find out the frequency. So if it takes half a second for one rotation, for one revolution, then it will obviously take 2 rotations in 1 second, right? So that means this is also equal to 2 pi n. Alright, so these are the basic formulae, and in the next video I'll be talking about some numericals. Alright, thank you.